lesson 2. We are in the thick of this course. And it's so important that I do the very best I can to get you to think mathematically. And the last lesson, using logic and reasoning to understand how to operate algebra with rational expressions, was, I thought, pretty spot on with the way understanding mathematics can make new concepts so much easier by assimilation instead of accommodation. Well, we're going to do a little more of that today. All right, so today we'll hit some review. It's not as heavy as it suggests there. Homework answers we're going to go over to do it, of course, and then we're going to quickly review. This is the review part of the day. The completing the square difference of two perfect squares, adding and subtracting rational expressions. Should have capitalized the R there. You know, I write a lot for magazines, and thank God I have editors. And then multiplying and dividing rational expressions. That's the new stuff for today, and reducing them as well. All right, here's your homework answers. 1, you know how to deal with this. Any issues or questions, make sure you get a hold of me or someone in the class. Okay, let's go to the next one. Okay, all right. So we've done a number of questions like this fourth one here with the border around the problem. This is a hint, something you might see again in the future. Today's do it, based on the last do it, all right? We're just changing it up. I love to do the concepts in a do it 2 or 3 times before I move on to a new type of question to really get you a chance to understand. It's that whole concept of spiraling back to the things you have to know. Coaching really taught me to do this, because you cannot. I remember one day, I coached wrestling and my buddy was my assistant, and there was a brand new girls basketball coach, and her team had gotten blown out in a game on, say, Monday or whatever. So after practice Tuesday, we were walking out of the wrestling room, getting ready to go to the bus duty, and that coach, her name was Kim. And we said, Coach Kim, how did practice go today? She goes, oh, great. I said, yesterday we lost bad and we had a really hard time breaking the press. We went over it today. I think we're ready for it. And instantly, both my buddy and myself started laughing. And we weren't as much laughing at Kim as much as innocent youth, because, we've been coaching by this point in time for 25 or 30 years. And as a coach, your team never gets it in a day. It just doesn't happen. Maybe after 3 days, they start to get it. Maybe after a week. Okay, now maybe you have significant progress to the point where they can execute it in a game. So we keep coming back to the same concepts repeatedly, so that hopefully after the 3rd or 4th time you see them, you and everybody in the class can understand how to do it. All right, get started on this. Stop and start time. Okay, so what we've got to be concerned about is their ages today and their ages in the future. Today, Terry is X years old, and Alan is 2 years older than Terry, so he's X plus 2. 4 years ago, Terry would have been X minus 2, and Alan would have been X. Yes, okay, yeah, Alan would have been X, because 2 years ago. For a second, I was thinking of last week when it was 4, or last lesson when it was 4 years ago. That's because it says ages 4 years ago. It should say ages 2 years ago. Sorry about that. Okay, so now, what do we know? We know that the product of the ages today, see where it says ages today, is 80 more than the product 2 years ago. It says 4, but that means 2. So the product of the ages today is X times X plus 2, and that's 80 more than 2 years ago, which is X times X minus 2. Distributing the x's, I get x squared plus 2x is equal to x squared minus 2x plus 80. Oh, look at that beautiful event. There's x squareds on both sides, so I can subtract them. And that gives me 2x is negative 2x. Danger, danger, danger there. Make sure you see that 2x right here, right? We always peek in front. That's a negative, so make sure you include it here, negative 2x. Add 2x to both sides. 4x is 80. That means x is 20. Terry's 20. Alan is 22. Okay. Praxis power. Performance is a function of preparation. That's why we spiral everything. And we really want to make sure that for everybody who takes that praxis test, the math section, that they maximize their score. So we dedicate some time every single lesson to reviewing praxis material. Give it a shot. This is like what we did before. Okay, so Lisa's managing a thriving marketing company. Her boss recently gave her authorization to increase her department's yearly party planning by 20%, bringing it all the way up to $1,500. What was the prior budget? So if you're bringing up 20%, the old budget was at 100%. It was the whole budget. You go up 20%, you're now at 120%. The original 100%, and you're going up 20. As a decimal, that's 1.2. So 1.2 times that original budget has to be 1250. Dividing by 1.2 times the original budget has to be 1500. I had the answer in my head. And then dividing by 1.2, the original budget, had to be $1,250. Okay. Try this guy. We haven't done one like this yet, but this is an old praxis question, so you got to be prepared for it, and we have been doing some work with fractions lately. What's the least common denominator there? Okay, so least common denominator is kind of a misnomer. It should say the least common multiple of the denominators. In this case, the denominators are 5, 8, and 10, so I list them. And I write the multiples of 5, 10, 15, 20, 25, 30, and so on. 8, 16, 24, 32, and so on. 10, 20, 30, 40, 50, and so on. So the least or lowest common multiple is the smallest number that's on both lists. And in this case, that smallest number is 40. Ding, ding, ding. Factoring, you guys should be really good at factoring right now. Again, an old praxis question. Lead coefficient other than 1. Those are nasty, but we can get them because we know how. Go ahead. Okay, so lead coefficient other than 1, there is no common factor. That means we're going to take the 6 lead coefficient, multiply it by the 2 at the end. That's x squared plus 7x plus 12. Factoring x plus 4, x plus 3. Maybe it's the guy on the left, maybe it's the guy on the right. Oh no, we're just factoring here. Sorry. Because we multiplied by the 6 to the last term, we have to divide back in by the 6. That gives me x plus, reducing 4 6, I get 2/3. Reducing 3 6, I get 1/2. So that makes, we're going to rotate that 3 up there, 3x plus 2 and 2x plus 1. Those are your factors. There's your choice C. All right, let's review a little bit of quadratic equations. Go ahead, get started. This isn't praxis review, but this is still very important word problems. If we're going to get better at them, we got to work at them. Okay, so sum of two numbers is 11. Product is 24. What are the numbers? Well, if their sum is 11, and we've done ones like this at least 2 times so far. First one's going to be x. That's always. If the sum is 11, then the other one is 11 minus x. Now, as a reminder, like let's say that the first number is 3, and their sum is 11. What's the other number? Well, it have to be 8, right? Because 11 minus 3 is 8. So that's arithmetic. Algebra is the thought process, the logic with variables behind that. So we said that if the first number was 3, the other one was 8 because 11 minus 3 is 8. So here, if the first one is x, we do 11 minus x. The product of these numbers is 24. So x times 11 minus x is 24. Distributing the x, 11x minus x squared is 24. Usually, students often wrongly think of left and right. I got to move to the left, I got to move to the right. It shouldn't be that way. We should think of getting everything so the x squared is positive, factoring with it negative is ugly. So I add x squared to both sides, subtract 11x. That gives me x squared minus 11x plus 24 equals 0. What two numbers multiply out to 24, add up to negative 11? That's negative 8 and negative 3. So 0 is x minus 8 times x minus 3. Maybe it's the guy on the left. Maybe it's the guy on the right. I know when I multiply and get 0, one of those guys or both have to be 0. Add 8 to both sides, add 3 to both sides. That gives me the answer x equals 8 and x equals 3. Those are the two numbers, okay? All right. Another one to try. Go ahead. Okay, so the difference of the squares of two consecutive even integers. So two consecutive even integers are going to be x and x plus 2. The difference of the squares. Now the bigger one, of course, has to be x plus 2. So that squared, that's the big one, minus the little one squared has to be 20 because that is the difference. All right, double distribute that. That gives me x squared plus 2x. Then I distribute the 2, another 2x plus 4. Then minus that x squared is going to equal 20. Oh, isn't this gorgeous? The x squareds cancel out. X squared minus x squared is nothing. So I get 4x plus 4 is 20. Subtracting the 4, 4x is 16. Dividing by 4, x is 4. Beautiful. X works out to be 4. So 4 and 6 are the two numbers. Let's do a little bit of a review of difference of two perfect squares. Let's just do the first one, then I want to review it with you, and then we'll do the next 3 in a row after that. Okay, so checking out that first one, I need two numbers that multiply out to negative 144 and add to 0, because there's really a 0x in the middle there. And that means you add up to 0, multiply to negative 144. So that's x plus 12 and x minus 12. Now, there's a formulaic way to approach this. When you notice that both the first term and the last term of the binomial, and there's a minus in between, it's called the difference for a reason, that minus sign, of two perfect squares, that you can square root both of them. So the square root of x squared is just x, and the square root of 144 is 12. And here's your x, first term of each parenthesis or package. And then there's your 12, positive 12, and negative 12. Okay, run out the rest of the page. Do the next 3. Go ahead. Okay, so for x squared minus 49, let's look at it this way from the square root perspective first. Square root of x squared is x. Square root of 49 is 7. So that'll give me x plus 7 and x minus 7. Of course, they have to add up to 0 because there's really technically a 0x inside there. And they have to multiply negative 49. Now, the quickest way is the square root technique with something like this. And you should learn to recognize it and be able to do that. I just think it's really important that you understand that this is not a gimmick, that we're still using the same factoring principle of AM. And it would always work right. It just so happens in this case, there's another way to do it, which is a little quicker and a little faster. But it only works because of that adding up to 0. Okay, the next one, the square root of x squared is x. The square root of 225 is 15. So it's x plus 15, x minus 15. And the last one's a little bit different, but by now we showed you one or two of these last time. The square root of 9x squared is 3x. So it's 3x plus 10, 3x minus 10. Square root of 100, of course, is 10. So the square root of 9x squared is 3x. You should recognize that. And square root of 100 is 10. Okay? So that's working with the difference of two perfect squares. And there should be a comfort level there now. Okay. Solve by completing the square. Let's see you do just the first one. We'll go over it in a minute. Okay. Look over that first one. Let's see what we come up with. Okay. Now, when we solve by completing the square, it's so very, very important to make sure that we get the x squared plus 12x on its own side. So in this case, we want to make sure it equals negative 3. Now, what's that key phrase that we have to remember when we do completing the square? What's that phrase? Half and square. Half of what? Half the number in front of the x, which is 12. So I make that x plus 6, because half of 12 is 6 squared. But x plus 6 squared does not equal x squared plus 12x. That's the half part gets you the 6. The square part makes it equal. I have to add 36 to both sides. Now, I added 36. It's already included in the x plus 6 squared. I add 36 to the negative 3, and that gives me, now I've added 6 to both sides. So I get x plus 6 squared equals negative 3x plus 36. Okay? Now, x plus 6 squared is 33. Now I square root both sides. Square root of x plus 6 squared is the square root of 33. When we square root a square, just leaves me with whatever's inside the radical, x plus 6 equals, and you could get the positive or negative out of this. Subtract 6 from both sides, x equals negative 6 plus or minus the square root of 33. Okay, try the next side. Go ahead. Okay. Now, half and square. So half of negative 20 is negative 10. So I have negative x minus 10 squared equals, now here's where we got to be careful, and maybe I could have done a better job of showing this out. I did it when I hand wrote it the other day. Half is the negative 10. Then I got to square that, and that's plus 100. Now, I've already added it to the left side because it's contained in the expression x minus 10 squared. If you double distributed that out, you would get x squared minus 20x plus 100. So when I have the x minus 10 squared, the plus 100's contained in that expression, then I have to do 9 plus 100. In other words, I got to add the square to both sides, which is 100. So x minus 10 squared is in 9 plus 100. So x minus 10 squared is 109. Square root both sides. That gives me x minus 10 equals plus or minus the square root of 109. Add 10 to both sides. X equals 10 plus or minus the square root of 109. That is solving by completing the square. Okay. Let's have you answer this question, which asks you a little bit about completing the square. Okay. Now, again, half and square. So Brian correctly used the method of completing the square to solve the equation x squared plus 10x minus 11 is 0. Brian's first step was to rewrite the equation as x squared plus 10x equals 11. He then needs to add a number to both sides. It should be x squared plus 5x equals 11. Squared equals 11. But anyway, what number did he add? He has to take half of the 10, which is 5, square it. That's 25. Okay. Now, let's compare how to add fractions with algebra and with the old way of doing it with just regular whole numbers. So this is what we worked on in the last lesson. Give it a shot. Go ahead. Okay. So for the first one, what you're going to do here is, okay, we need a least common denominator, and you may realize it's 40, but another way to do it is to say, okay, I'm going to take this denominator here because it's missing from the 8 and multiply by that denominator over itself, 5 over 5. The 5 is missing the 8, so I put the 8 over 8. Now I'm automatically guaranteed a common denominator, in this case, 5 times 8. So I get 15 over 40 plus 16 over 40 gives me 31 over 40. Now we're going to use the same strategy on the middle guy. Let's see if you remember how, and then if you don't remember how, we will get into how to do it to remind you. Okay, so what does this denominator of A have that the other one, or need that the other one has? It needs a B, so this is why I put B over B. What does the denominator of B need that the left side has? That would be A. Oh, that should say A over A, not X. I don't know why I have an X there. It should say A over A. So that would give me 4B plus 3A, 4B over AB plus 3A over AB. Now I add them up. I get 4B plus 3A over AB. And by the commutative property, because we usually go in alphabetical order, not that it's necessary, I get 3A plus 4B over AB. Oftentimes we see this in a multiple choice question, and we may have arrived at the solution 4B plus 3A over AB, but the choice might be 3A plus 4B. Okay? Now this is a little bit more challenging. Let's try it where we have to do a little factoring first to figure out the common denominator. Go ahead. Okay, so let's take and factor each of these denominators. The denominator on the left is 3 times x minus 2. The denominator on the right is x plus 2x minus 2. So as you can tell, the denominator, both denominators have an x minus 2. But the one on the left needs from the right an x plus 2. And the one on the right needs from the left a 3. So on the left, I do x plus 2 over x plus 2. And on the right, I do 3 over 3. That gives me, in the numerator on the left, 2x plus 4, right? That's what you get when you distribute the 2 to the x plus 2. And then the denominator. And then on the right, I got 3x and then the denominator. So I have my same denominator, so I'm going to leave it. And then on the top, 2x's plus 3x's make 5x. So 5x plus 4 over 3 times x plus 2 times x minus 2. So we've seen this 3 times now. We saw it in class after lesson 1. We saw it on the homework for lesson 1. And now we are seeing it as part of our review of the work that we've been doing so far. And you just know that we're going to see more of these questions, like at least 3, 4, 5 times before we get through thinking we've seen it enough to know it. All right, so while we're thinking about fractions and rational expressions, rational just means fraction, okay? And by the way, it's rational means fraction because the beginning of the word rational is ratio, and a ratio can be expressed as a fraction. So what are we looking to do here, okay? What we're looking to do is reduce each of these. Let's reduce just the first one, 15/20ths, and let's see how you do that. So a lot of students will take out their calculator and they'll type in alpha y equals 15 over 20 and bam, the answer spits out 3/4. That's great, but that's not the way you should be doing this in terms of understanding what's going on, because the calculator is not going to be so kind when we start putting in variables. Remember, it's the thought process we want to get to, okay? Remember the old expression, it's the thought that counts? That's what we got here. It's the thought that counts. So I asked myself, what's the greatest common factor of 15 and 20? And the answer to that is 5. So 15 is 3 times 5. 20 is 4 times 5. Now, here's what's really going on. What does 5 over 5 equal? 1. And that means that 3/4 times 1 has to be 3/4. So I can, once I figure out how to write it this way, 3 times 5, 4 times 5, I can cancel them out. And the answer that remains is 3/4. It's kind of like 15/20ths is the number 3/4, or the fraction 3/4, all dressed up in a Halloween costume for like a masquerade party, okay? And you need to lift off the mask and see who's inside that costume. And the way we do that is we find the greatest common factor and we reduce it out. We cancel it. Okay. Back in the day, we used to say we kill it, die, die, but the world has gotten much more sensitive now. So we don't say that anymore. We say cancel. I used to say canceling is what little old ladies do. Now it's what cultures do. All right. Try 10/20ths. Give it a shot. Okay. What do they share in common? They share a 10 in common. So 10 is 1 times 10. 2 is 2 times 10. Now, they also share a 2 and a 5 in common. And you might have expressed it that way. However, the problem is it's not the greatest common factor. It's a common factor. And if you did that, then you would have to do it again one more time. Okay? 10s go die-die. Good. Now we're going to take the same exact ideas and apply them to algebra with variables. And the really cool thing is it's so much easier because you don't need to first recognize that 10 is the greatest common factor or 5 is the greatest common factor. You can just look at it and start canceling as long as there's no addition or subtraction in between. And we're going to talk about that. Well, we did that the other day, but bottom line is as long as there's no addition or subtraction in between here, we can just start canceling. So I'm going to, x over x is just another way to say 1. Like 5 over 5 is 1 or 10 over 10 is 1. Anything divided by itself is 1. So I cancel out the x's. Now the y's on the top, y to the third means y. Sounds like a little kid, right? Y. On the bottom, just a single y. So I can cancel one of the y's with one of the y's on the bottom, leaving y squared left. Or you could even think about it like the division of exponents rule where we subtract exponents. 3 minus 1 makes 2. So y squared is the correct answer, okay? So we just subtract those exponents. Okay, try the next one. Go ahead. This combines a little bit of number with a little bit of variable. So, in this case, 3/9 can be reduced. They share a 3 in common. And with the a cubed over a squared, subtracting exponents, there's a single a left. So 3 over 9 reduces to 1 over 3. I don't need to write the 1, but if you wrote 1a, that's fine. 3 stays the denominator, right? Because 3 is the greatest common factor. And then a to the third over a squared, I can look at it as I cancel 2 of the 3a's in the top, or I subtract exponents. That leaves me with 1a left. So that's how we reduce a rational expression. What about multiplying and dividing rational expressions? Well, the cool thing here is you just do more of what you're already doing, okay? Because like where we just had 3a cubed, that means 3 times a cubed over 9 times a squared. So it's exactly what you've been doing. You just do more at a single time. So let's try to look at this first one. What a lot of students do is they say, oh, I'm going to multiply. So 3 times 2 is 6, and 7 times 3 is 21, and they get 6/21. And you can do that. It's not wrong. I just don't think it's as quick as you should be doing it. And then, of course, 6/21 reduces to 2/7. So again, you could multiply it out. 3 times 2 is 6. 7 times 3 is 21. And then reduce it to 2/7. And then you got to go through the process of either doing it on a calculator or realizing that they share a 3 in common. But you could have just canceled from the start. Just cancel out the 3's because 3 over 3 is 1. By the commutative property, the order doesn't matter, right? The commutative property of multiplication. So 3 over 3 is 1. So I just cancel out the 1. I'm left with 2/7. So with one quick stroke of the pen, cancel out the 3's. 2/7 is the correct answer. Try the next one. Go ahead. Okay, one quick stroke of the pen is the way to do this, but just in case you're clinging tightly to the old way of doing things, 4 times 1 is 4, 5 times 4 is 20. 4/20 reduces to 1/5, or the quick stroke of the pen, which should say 4/5 over 1/4, cancel out the 4's and you're left with 1/5. Just imagine the 4 there and the 5 and the 1 and the 4. Okay, now you don't have a choice in the middle column because there is no a times b equals 20 or a times b equals 18. Doesn't exist. So you just look for something in the numerator over something in the denominator. It has to be numerator over denominator so it equals 1 that you can cancel here. Go ahead. That's it. You're done. It's that quick. Cancel out the b's. The answer is A over C. How simple is that? Anything in the top, as long as it's the same in the bottom, you can cancel them because B over B is 1, and 1 times A over C has to be A over C, whatever A over C is. Okay, try the next one. Look at that, x over x, I can reduce it, and then 3/9 we mentioned before, that's really 1/3, right? Because 3 divides into 3 once, 3 divides into 9 3 times. So I cancel the x's first, and 3/9 is 1/3. And sometimes they get a little more complicated looking yet. Try the last one. So part of this is really easy, right? We can cancel the y's out right away. Of the x squared and the x cubed, there's one x left over in the bottom, right? Because there's more x's in the bottom. There's x, x, x in the bottom, x, x in the top. So I can cancel 2 of them in the top with 2 of them in the bottom, but the one left over is in the denominator. Cancel out the y's, and I'm left with 2 over 3x, right? The 2 stays, nothing reduced that or canceled it. 3 stays, and 1x left over here from the bottom right. So that's your multiplying and dividing rational expressions. If for any reason you didn't understand that, go back and watch this section of the video again. Now we're going to do it again, but a little more complicated looking. So before we go any further, I want to talk to you about love. Every student understands that there are certain things about love and relationships that the whole world knows. What is the skeeviest, most low-down, horrible, evil, awful, pathetic thing that one partner can do to another partner in a relationship? You know it. Cheat. You cannot cheat on them because with a relationship, there is a bond. And that bond exists so that you cannot break it apart. If you break that bond, you've done something wrong, okay? So let me show you what I mean. On this number 1, you cannot start canceling these x's right away and say that the answer is 3x squared minus 4 over 1. No. There is mathematical matrimony going on here, and they cannot be canceled in any way, shape, or form. Years ago, there used to be a commercial on TV for Kibbles and Bits dog food. And the little kid would start singing, Kibbles and Bits, Kibbles and Bits. All that he wants is his Kibbles and Bits. Kibbles and Bits, Kibbles and Bits. All that he wants is his Kibbles and Bits. Well, when you go to simplify, it's factor and cancel, factor and cancel. All that you do is you factor and cancel. Factor and cancel, factor and cancel. All that you do is you factor and cancel. So we got a factor here. I factor the numerator, I factor the denominator if necessary. When I factor the numerator, I get 3x minus 4 times x plus 1. Denominator was x plus 1. Now, let's go back to that relationship situation. If they both agree to break up and then they go out with other people, is that evil, horrible, despicable? Or as Duffy Duck would say, despicable? No, because they agreed to break up. The breakup was mutual. In this case, when we factor, we've broken them up. Apart, what we've done is we haven't really broken them up like a relationship breakup, but we've now gotten it to the point where I can cancel x plus 1 over x plus 1 because anything over itself is 1. And x plus 1 over x plus 1 is 1. So I cancel those, and my final answer is just 3x minus 4. So it's factor and cancel, factor and cancel. All that you do is you factor and cancel. And then you look for anything that equals 1, which is anything divided by itself. Okay, try number 2. Go ahead. Now, the previous set of questions on the previous PowerPoint slide, those questions didn't need to be factored because there were no pluses or minuses in between. This one does. So you cannot cancel the 2's here. You cannot cancel the x squared. You cannot cancel the x's because there is mathematical matrimony going on here. But you can factor. So you factor. Now you can see why we spent so much time factoring to get good at it. I factor 2x squared minus x minus 3 into 2x minus 3 times x plus 1. Then I factor 2x squared plus 3x plus 1 into 2x plus 1 times x plus 1. Well, looky right there. I got x plus 1 over x plus 1. Cancel those suckers right there. Bam! Done. And I'm left with 2x minus 3 over 2x plus 1. That's the correct answer. I cannot cancel the 2x's because the 2x in the numerator is bonded to the negative 3. 2x in the denominator is bonded to the positive 1. All right. Number 3. Factor and cancel. Factor and cancel. All that you do is factor and cancel. Go ahead. Do number 3. Okay, so you factor the numerator. That's the difference of two perfect squares. X minus 3 times x plus 3. And then 3x squared minus 8x minus 3 factors 2. 3x plus 1 times x minus 3. Again, this is why it's so important to have these factoring skills. Oh, look, I've got x minus 3 over x minus 3. Cancel. That leaves me with the final answer of x plus 3 over 3x plus 1. Can you cancel this 3 up here with the 3 in front of the x? No. Mathematical matrimony. We cannot do that. Let's do another set. This time, we'll start with just the first one. Then we'll do the next two. Factor and cancel. Factor and cancel. All that you do is you factor and cancel. Okay, so x plus 5 over x plus 4 doesn't need to be factored, but the fraction or ratio on the right needs to be. So x squared plus 3x minus 4 is x plus 4x minus 1. X squared minus 25 is x plus 5x minus 5. Ooh, look at that. I can cancel the x plus 4s and the x plus 5s. That leaves me with x minus 1 over x minus 5. And as we've emphasized, you cannot cancel those x's. They are mathematically matrimony bonded. Okay, try numbers 2 and 3. Go ahead. A little trick on number 3. You may remember from high school, you may have never seen it because this is not emphasized like it used to be. Okay, so for number 2, I'm going to factor out the x on the upper left. So it's x times 3x minus 2. X plus 2 stays in the bottom. Numerator up here, that's 3x plus 2 times x minus 2. And in the denominator, more difference of two perfect squares, 3x plus 2 times 3x minus 2. Oh, look, I could cancel the 3x plus 2s. I could cancel the 3x minus 2s. Looks like about it. All canceled. Final answer, x times x minus 2. Make sure you put it in parentheses over x plus 2. You could put the x plus 2 in parentheses too, but it's not mandatory because it's not being multiplied by anything. It's all there is. But in the top, you got this x hanging out here on the left. And if you don't put the parentheses in between, it changes what the expression means. Okay, now number 3, we're going to factor and cancel. So we factor and we get 2 times 3y minus 1 over 3 minus y. Then we get y minus 3 Oh, I factored this wrong. Let me correct this here. Okay, let's go back to the slideshow. I made a sloppy mistake there. All right, that one's done. That one's done. Oh, God. Okay, back to where I was. Good. Sorry for that commercial delay. Now, I factored y squared minus 6y into y minus 3 times y minus 3. Brief review. Rewind. 6y minus 2 is 2 times 3y minus 1. 3 minus y stays the same. And if I factor 3y squared minus y, the greatest common factor is y. That leaves me with 3y minus 1. So 3y minus 1 over 3y minus 1 is 1. I cancel them out. Then I also put slashes through 3 minus y and y minus 3, and they're not the same thing. In fact, they're the negatives of each other. So when I have y minus 3 over 3 minus y, a subtraction, and I switch the order, I have to remember to include a negative in the answer. So the final answer is negative 2 times y minus 3 over y. I'm sure we'll get to some more examples of that negative reduction later. Now, dividing rational expressions. How do we do that? Well, we're going to start with an example from elementary school, so you can bet that arithmetic has everything to do with algebra, as we have emphasized in the course during the year. And I know why you flip and multiply when you divide fractions, but I didn't have time to cover it today. Hopefully next time I'll get time to cover that. Let's talk about how to do this. 3/5 divided by 4/5. What you're going to do is flip and multiply the second fraction. Not elementary school, but in middle school, there was one of our teachers who used to have the class sing, "Keep change, flip." Can you tell that I was cut from a church choir? I was pathetic. Years of therapy. No. 3/5 divided by 4/5. I take the second one, I flip, and then I change it to a multiplication. Again, I hope to show you one day why you do that, because I do know how. Now it's exactly like what we just did, and I've been trying to emphasize the importance of assimilation over accommodation. And now this looks exactly like the previous slide. You know how to do this, baby. You cancel the 5s. The answer is 3/4. Now it's the same thing with these uglier, if I can use that terminology, expression. But it's the same exact process. You got to flip and multiply. But with algebra, you're also going to factor first. So now it's flip, multiply, factor, and cancel. Give it a try. Quiet. All right, my dogs are barking. I'm sorry about that. I think my wife's getting home. So I flip and multiply, and I factor. 9x squared minus 49 is 3x plus 7 times 3x minus 7. 0, quiet. Quiet. And 3x squared minus x minus 14 now goes in the bottom. It's 3x minus 7, hush, times x plus 2. And in the top, it's 2 times x plus 2. And once it's factored, this now looks like the previous slide. All you got to do, cancel what you can cancel. I cancel the 3x minus 7s. I cancel the x plus 2s. 2 over 6 simplifies to just 1/3, or 3 in the bottom. Your final answer, 3x plus 7 over 3. 3x plus 7 over 3. And as we mentioned before, you cannot cancel the 3's. Mathematical matrimony. Ziva, hush. Try the last one. Remember, flip, factor, and cancel. Shh. Quiet. Good girl. Okay, now I flip and I factor. Okay? So, for example, when I factored x squared minus 4x plus 3, I put those factors in the numerator. X minus 1, x minus 3. So I just switch places when I do the factoring. I take the factors of the bottom, put them on the top, take the factors of the top, put them on the bottom. There they are, x minus 3, x minus 2. You don't flip the first fraction. That stays the same. You only flip the second fraction. So then this becomes x squared plus 3x minus 10 is x plus 5x minus 2. And I factor 2x minus 2 to 2 times x minus 1. I cancel the x minus 1s, the x minus 3s, and the x minus 2s. That leaves us with x plus 5 over 2. One last quadratic equation word problem for the day. Give it a shot. Okay, so we've got a rectangle. Length is 10, or the width is 10 less than the length. So length times width, x times x minus 10 has to equal 171 in this problem. X squared minus 10x equals 171. Subtract it, get it all on one side. Factor. That's x minus 19 times x plus 9 equals 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Add 19 to both sides. Subtract 9 from both sides. That gives me X is 19, X is negative 9. Cancel that negative 9 because this is length and width. You can't have a negative. 19 and 9 are the correct answers. Happy recap. Anything over itself is 1, so we can cancel it. Word problems, same as it's always been. Underline anything important, use it, check it off as you go along. And dividing fractions, don't forget to flip and multiply everything after the division symbol. Not